Hello and welcome to my tech farm. My name is Igor, and what I have here is PLA filament from BIQU. First they wanted to send me the 3D printer, and then they said they're out of the stock in European warehouse, so they will send me PLA filaments. I said okay, and usually I ask for two different types of the filaments so I can compare them in one video, but here I got only one spool. So, but to be more interesting this test, I will use my standard test specimens, so the results are comparable with other experiments which I did in earlier videos. Okay, so let's see what's in the box. I can see a nice vacuum package spool. Let's open it. Few interesting informations on the box. It says after their improvements, the toughness and the fluidity is improved, and it provides easy of printing and good mechanical properties. So that's why I will test it mostly from the mechanical aspect. Okay, let's see the spool. Here we have a hole, so we can see how many filaments we have on the spool, but there is no scale on it. On the other side we have stickers, and on the smaller sticker we have some basic informations like printing temperature between 205 and 225 degrees Celsius, bed temperature between 30 and 60 degrees Celsius, printing speed between 40 and 80 millimeters per second, fan 100%, and net weight of the spool is 1 kilogram. I will print first the print tower, and then I will print the test specimens, and usually I go closer to the higher limit of the recommended print temperature. So I print everything on 220 degrees Celsius. Print tower from 230 to 190 degrees Celsius. Printing is finished. I was worrying a little bit for 190 degrees Celsius. And here it is, absolutely no problems with the printing from 230 down to 190. Perfect overhangs, absolutely no stringing on any temperature. Only I noticed that the bridging has a little bit bigger stomach than regular PLA. I'm not sure is it visible on camera too. But all test specimens I will print on 220 degrees Celsius. I got comments that I should have broke these small parts to see the layer adhesion. I will test layer adhesion separately, but it's not that easy. I don't think it's designed to be broken, but let's try it. Okay, this was too easy, but these four are quite equal. But I will test the layer adhesion separately on 220 degrees Celsius. Test specimens for layer adhesion and for tensile strength. All I have to do is to cut these supports. Because these are my universal test specimens for those materials which don't have that big layer adhesion. During the cutting I can notice that it is not brittle material like regular PLA. I will see an impact test. And these are test objects for other experiments like impact, bending, shear, and twist or torque tests. Oh, removing of the supports is easy. For tensile strength test I'm using these test specimens printed in horizontal position, and the smallest cross-section area is 4 by 4 millimeters here. And this is my test setup, so I have here a chain hoist and a crane scale, and there will be my test specimens attached here at the bottom. As you can see, in both cases they didn't broke on the smallest cross-section area, and this means that something is wrong with the layer adhesion. So I'm very curious for the next test. Layer adhesion test. So these test specimens are printed in vertical position. They broke too easily, so this means even printed at 220 degrees Celsius, the layer adhesion is quite weak. In shear stress I will use these 5mm diameter pins. As you can see, the shell cross-section area is doubled. And again I can see some marks of the weaker layer adhesion, so here and here you can see that layer detached. So definitely I think this should be printed on even higher temperature, but I was already close to the maximum recommended printing temperature. The bending test is based on ISO 178, something similar. The distance between supports is 50 mm, and I will record the load on 2 mm deformation and the breaking load in kilograms. And I believe we can perform even better if those layers would stay together. This is my torque or twist test. So I have this test specimen. In the diameter it is 6 mm and the cylindrical part is 30 mm. This side goes into the wrench and the other side goes into the vise. And I will rotate it, follow the torque, and with the upper camera I will check when will it break. Point 4. I think it's already broken, and again the peak is 0.4 Newton meters. And now, as I expected, so because that weaker layer adhesion, it performed very badly even in this torque test, and definitely it can be very visible that layer separated from each other. This is my impact tester, and first I have to record the zero position without test specimen here. And then I will insert here the test material, and it will break it and swing to the lower position, and from difference in height I can calculate the potential energy used for breaking this test material. The zero position. And the difference between two positions is 141 millimeters. Usually the regular PLA has this difference approximately 10 millimeters, so this is absolutely not brittle material. And here you can see the equation. So the energy used for breaking the test specimen is 0.69 joules. In this experiment I want to record the temperature when the test specimen made the first deformation. I have here the M10 nut as a small load. I think it performed better than regular PLA, but I have to analyze the footage first. I reprinted these vertical test specimens on 235 degrees Celsius, and it can be seen that it is really on the edge of the printability because some stringing appeared. Let me go closer. So even this is 10 degrees above the recommended maximum printing temperature. So I'm very curious what will be the layer adhesion in this case. So these are printed on 220 degrees Celsius, and these are printed on 235 degrees Celsius, but also the layer adhesion was quite weak. And now the conclusions. Well, I started from this text on the box, which has good mechanical properties. This is quite new filament, and I can see some space for improvements. I mean, this is very promising. You saw that impact test. I think this is the second best filament so far in my experiments in this impact test. But in all other experiments it performed quite weak. And I believe that the reason in every case is that weaker layer adhesion. You saw I even tried to print it on 235 degrees Celsius, which is 10 degrees above the recommended printing temperature, but even there I get a quite weak layer adhesion. I mean, sometimes this can be an advantage because it is easier to remove the supports, but I think in most cases this is not a requirement for most users. All the results you can download from my website in PDF form, and if you click on this link, then you can get the list of videos where I use the same test specimen dimensions, so if you can compare those results with each other, because on every page you can download the results in PDF form. I hope I can give you some useful information. Thank you for watching and happy printing!